So, well, hi there. Now this is the DIY radio learning package, the version that has never been released. Why hasn't it been released? I was making this package and I wanted it to make it a .zip file that is uploaded on some random file hoster, and you can download it via a link that I sent you on a video. And in Germany, if you make a website and if you put anything that could anyhow be an opinion about something on the website, and it's not a family private website, which with some information just important for your family and friends, and with some information for anyone important, you are supposed to add your address to it, your complete phone number, your email address, and exactly the address where you live. If you don't do that, then they will catch you. You will have to pay a fee of 50,000 euros. And I made a kind of website. It's in .html, but I wanted it to put it in a folder and upload it to a web hoster, and so it's not a website. And this is how I want to not make this law counting for me. But then I was making the website, which is not a website. It does have a www address, but I was making this stuff, and I was sure with my addition, put it in a folder and upload it at a web host as a zip file. I'm not supposed to make this law to add my address, but I was wrong. After I was putting months of work into this stuff, I found out that no matter if you upload it on a file hoster or even if it's just a PDF file, you are supposed to add your address to it. There were many people writing some ideas to me, but I've done really some research over weeks on various law sites, and I found out that there's no way to ungo or to let out this law. I would be able to make an ebook with this site, but the problem was on the providers for ebooks that I found, you are supposed to be paid for what you do. I can't make an ebook and sell it for free on Amazon. You are supposed to be paid, and I don't want to do that because it's tricky. For the paper you have to fill out for the state where it's written in how many money you have earned. I would always have to have a look at this, and I simply don't want to do that. The project has not been finished since I stopped with it, but I was sitting on it for really some long time. And this is the first page. You get your introduction. Of course, this is the alpha version. I never got to the beta version and neither got to the finished version. And on the first chapter, you are going to learn about electronic components and schematics. Here's the battery schematic, and next thing is LED. And it's always built up the same way. You see a small picture. I think you could click on the picture in a later version and it will make a bigger picture. And then you will have your explanation. Of course, this is just the alpha version with a very short explanation, but you here have the test for the LED, and you will see that I've written the values to the components so you can see how to build them in. I also have made a pretty big picture so you can sure rebuild it. And then you have the schematic, of course, and you will learn how the schematic works and stuff like that. And then we go ahead and make different experiments. Resistor, a variable resistor. You can dim these LEDs. You can light up one. You can light up this. You can light up both and dim these. That's what you test in this experiment. Here with a diode, and you will notice, or you will learn, that the diode is polarized. If you put it in the right direction, it will allow the current to flow. If you put it in the wrong direction, it won't allow the current to flow. So right direction, LED will light up. Wrong direction, LED will stay dim. Okay, next thing is switch, simple experiment. Here's a switch that has two positions. You will see that you can activate either this or this LED, but not both at the same time. Capacitor, electrolytic capacitor, non-electrolytic capacitor. Here typical applications for electrolytic capacitor, typical applications for ceramic capacitor, and I would have also made another typical explanations for a foil capacitor. But as I said, this is the alpha version and not finished. So you have one switch to charge the capacitor and one switch to discharge the capacitor. And if you, in this experiment, you will learn if you decrease or increase the capacitance of the capacitor, the amount the LEDs will stay on is varying. Next thing is transistor, NPN, PNP, typical transistor circuits. Here you have a super bright LED with, I think it was some 1 meg or something. Let's see the schematic. Yeah, 100K resistor. From base to plus with the LED. You will see this LED is barely lighting up, but this one is pretty bright, and then you will see that this transistor is amplifying. You will switch the LEDs later, you will see that this one does not really light up visible, but this one is really bright then. Phototransistor, and here's the part where it's not really finished. Microphone, simple ECM microphone test. You can blow on the microphone, you will hear it on the headphone. And here it's not finished. Here inductors and audio transformer. Next chapter is a little bit more experiments. And here you have the advanced experiment for capacitor. This is simply a signal generator with a output stage, and you will see if this LED is flashing, either this or this LED will be turned on. So we'll see that this capacitor can generate AC current if you make the right circuit. Later you will make some other stuff, capacitor on real AC. You will see that the LED, the light bulb is light up through the capacitor because of AC. And the speaker here can hear the tone. You can adjust the frequency here. Coil on AC and on DC and AC. You will see if you add a battery here, push the button, the LED, the light bulb will light up. And no matter what you do, if you short the output of the coil or if you don't short it, it will light up. So now we have, on the next experiment, we have AC on the coil. The light bulb won't really light up, but if you push the button, you will short the output of the transformer, current will flow, and the light bulb will light up. So you will learn that the transformer won't transform DC, but it will transform AC. And as I said, this is just the alpha version. So I would have improved that really much, the layout and the logic and all the explanation. Also, of course, there would have been an English version. Coil and resonant frequency, if you tune the resonant frequency, the light bulb will go out. And if you untune the resonant frequency, it will go on again. It's just a basic version. I don't know exactly how it worked, but it worked very well. Basic microphone amplifier. Here you have a 2-transistor microphone amplifier, and also you notice here the potentiometer is on the output on the headphone side, and you will later learn that it's better if you put in the volume control on the input of the amplifier, but it's all explained here and there's all this stuff. Okay, we have Class C amplifier, but it hasn't been finished. As you can see, here's the AB amplifier that will drive a loudspeaker. Here you have a microphone, talking to the microphone, you will hear it in the loudspeaker. Okay, next chapter is more advanced. We are going to transmitter stuff. You build your transmitter, testing transmitter. This testing transmitter is going to be used in the first version of the learning package all the time. You can flip the switch either this or this direction, and that will make the signal, the test transmitter, either transmit a tone, a signal tone, or if you switch it on the other direction, you can talk into the microphone and you will have your voice be transmitted. And here we go ahead and build the first simple, straightforward receiver. Very straightforward, as you can see here. It's just a diode and a resonance circuit, and then it's amplified. But it does, or it did, in my experiments at least, work. Then we go ahead and build a super regenerative receiver, first with the headphone. Later we add the amplifier. Here, an amplifier added to the super regenerative receiver, and so far and so on. And here it stopped. The last thing would have been a regenerative receiver, but it stopped here. Okay, now the next part. This is the newer version. So the ones you have seen I made some years ago, and then I stopped it. I was not interested in it anymore because I think who would be interested in that or something like that. And this is the new thing. It's like a restart. And here we go ahead, and this one is all transmitting on medium wave. So I can pick it up with a nearby standard radio. For the first versions, we were using a 27 megahertz, which you can pick up with a standard radio. But this one is all working on medium wave, and it's with the Verfügung 1/2010 with the inductive transmission stuff that I told you before. Eventually, I told you before. And here we start with the first Colpitts oscillator, and here I have the schematic, typical oscillator, and I want to learn you that if you change either the coil or the capacitance, it will affect the frequency. And they are really making experiments. What happens if you add a capacitor here, if you add a capacitor here? You can simply experiment and work with this circuit stuff. And also it's all built on a breadboard, solderless breadboard, but as you can also see, this one is not really finished. But I've put in weeks or months of work into this. And here you can, for example, see various trimmer capacitors, tuning capacitors, various types, two connection capacitors, 3 connection capacitors, and you have here you can see various positions, low capacitance, half capacitance, maximum capacitance. That would have all been explained. Here's a 2 connection minimum capacitance, half capacitance, maximum capacitance, and all this stuff would have been explained. Here I haven't even finished it. So you have another schematic with the coil from base to ground, and you can tune the frequency here and so far. And I would made it like this: one chapter oscillator, one chapter modulator, one chapter amplifier, and so far and so on, going from a simple one transistor transmitter up to a super complex, if you want to call it like that, a transmitter with many stuff in it, a super regenerative receiver, a super high-tone receiver and stuff like that. I was having so many plans for this. Oh, this is using an integrated circuit oscillator or transmitter. It's just an oscillator. Yeah, as you can see, this is absolutely not finished. Although it looks not much work, but I've put in really much work. So this is kind of how it would have looked like. This is buffer amplifiers, and here you can see a small picture. And here's a schematic for a typical oscillator. If you bridge this one, you will see that if you add a small capacitor here, the frequency of the circuit will change a little bit. If you add a big capacitor, it will change really much. And what you're going to learn in this chapter is that you can add a buffer amplifier, and a buffer amplifier will help to get the frequency more stable. So if you bridge this one, the frequency here won't really change much because you have the buffer amplifier, and that is the second chapter. And these small pictures you see here, where the buildings are made, and you can also click them on in theory if it would have been finished, and you would get a big picture of it. For example, like this. This looks a little bit chaotic, but I would have made arrows and explained what is every resistor. You can see this one is a 100K, this one is a 6.8K, this one is a 1K. Of course, if you have enough knowledge to know the color codes of the resistors. Okay, yeah, the pictures would have been bigger, probably. I don't know it. It hasn't been finished. And here's some of how a transmitter would have looked like. This is experiment for modulation. Yeah, that's collector modulation. Here, collector modulation. And you would learn different ways to modulate the signal to make a yeah, this looks really messed, but if you have a look at it, if you have a close look at it, you can actually rebuild every single bridge on it, every single component on it. You can rebuild it, although it looks really messed. Here's amplitude modulation with one diode. I'm using this diode as modulator. Here's the schematic. Here is this diode. This diode is making the amplitude modulation. And class C amplifier, AM amplifier. And there's even a really weak FM transmitter. So this one is transmitting in the FM band. And I've tested it with some legal FM transmitters, and this one is even weaker. If you don't add an antenna, it is even weaker than the legal FM transmitters, so no problem. Here you can make MPX, you can make a stereo transmitter with it. If you use MPX signal from a signal source, and so far and so on. This chapter 6. Here we are going to talk about receiver circuits, is what this means. And here I've just written stuff. A straightforward receiver, super regenerative receiver, single conversion receiver, blah, blah, blah. And even I made an audio circuit, I made a limiter circuit. That means it will hold the audio volume always on the same level, that it will work for all transmitters. I've really built a system in. Here's some kind of summary. You can click, for example, Colbit's oscillator, how it has been made, buffer, and so far. Of course, this is not finished. There's no value on the coil, there is no value on the capacitor, on the resistor. This would have all been added in the final version. But here are some other things that I made. So I've really put some work in it. Here you can see pictures. So you can see all these pictures that are not yet in the project, but I've made some pictures. As you can see, you can learn trimmer capacitor, that this one is RF like hot and this one is connected to ground, and so far and so far and so on. So I've put really much work in it. You can use a solderless breadboard for this, and there's a small solderless breadboard and stuff like that, and would have all been explained, but as you can see, for loss and also for the frustration out of the loss, I didn't really finish this project. But I was having a good idea, I think. It would have been a really, really big informative learning package, how to design a transmitter, what do you need if you want to build a transmitter, and how to design a receiver, and all about receiver and transmitter. Okay, I leave you with that. Best regards, Stefan.